Hello and welcome to our Business Analysis Tools group coursework. My name is Kirsten Berry.
Hi, I'm Michael Doyle.
Hi, I'm Tanika Stewart.
So today we will be covering what is forecasting and why do we study it. We'll then briefly run through various forecasting models. I'll have a detailed analysis of our data. We'll then have a conclusion of the analysis and our recommendations for the operations manager. And then finally, we'll have how to improve your forecasting model and our group reflection. So, what is forecasting and why do we study it? Much like a weather forecast, businesses use forecasting models to look into the near future. This helps them to prepare and make the best decisions for their company. This means that companies can predict the future with more certainty. This could be in a positive way, such as an increase in their own sales or profit, or in a negative way, such as seeing as a competitor emerge onto the market and steal some of their customers. However, for those using forecasting models, the risk of any of these circumstances getting out of control is reduced, as they can normally be monitored by the models. One of the major circumstances forecasting models can prevent is a company having any wastage. This is a huge problem in those companies dealing with perishable goods, as any wastage each day equates to a loss financially. There are many types of forecasting model. All techniques can be divided into three sections: causal, time series, and qualitative. Causal methods use a variety of factors, time series methods use historical data, and qualitative attempt to include the subjective. I will now briefly cover 5 of the models you could potentially use when forecasting. Firstly, there is moving average, which is a time series technique. This is done by calculating the average of the most recent number of periods and using this average for forecasting the next period. An expansion of this is weighted moving average. This method allows you to weight the data. For example, you can weight the most recent data, which may be more relevant. The advantage of these two methods are it's quick and easy, which makes it more cost-effective, and only a small amount of data is stored. The disadvantages are it requires more historical data than others, and they do not take into account trends. The next forecasting model is the drift method. This is a variation of the naive method and allows the forecasts to increase and decrease over time. The amount of change over time, called the drift, is the average change in the historical data. Finally is exponential smoothing and Holt's method, which I will now cover in more detail. Exponential smoothing is a type of weighted average that applies declining weights to all past data, with greater weighting placed on the more recent data. This model is used widely in the business environment, especially when monitoring competitors. The formula is as follows. What we are trying to find is the new forecast for the time period, plus 1. The actual value starts the formula. The formula also includes a smoothing alpha value, which is used to adjust the weighting where alpha is between 0 and 100%. Holt's method, 1957, is a technique that takes into account trends. Within the business, it is used within sales, which is particularly relevant to the set of data our group was given. The formula is as follows. Forecast for the next time period equals current level plus current trend.
I'm now going to explain how we analyse the set of data given to us. The source data is visible on the left-hand side of the screen. The first step was to estimate a value for the missing data in time period 10. To do this, I used a two-way 3-point weighted moving average. This takes in data from the previous 3 and the following 3 points of data and applies a weighting bias to the data in the closest proximity to the data point. The result given was 29,002, which when compared to the results around it looks like a plausible value. Following on from this, we then analyse the full data set and recognise that there are some potential outliers in the data. In periods 18 and 24, both have considerable negative jumps where there is a clear overall upwards trend.
Now that we have analysed the data set, we are able to begin using forecasting methods, starting with exponential smoothing. The formula used in Excel is shown for the cell C10. The formula takes the previous forecast plus alpha, which is a smoothing constant between 0 and 1, multiplied by the previous actual data minus the previous forecast. For C10, this result is actually around 2000 units out. However, you can see from other points that it is much more accurate. We then copy down the formula all the way to C32 to give us a figure for time period 25. To achieve the best possible figure for alpha, we had to work out the mean average deviation and use the Excel add-in solver. To find the mean average deviation, we use the ABS, or absolute function, to give an absolute deviation between the forecast and the actual results. Once copied all the way down, we then had to find the mean average deviation by using the average function. This gave the average deviation of the whole data set. To find the best possible solution, we used solver with the following parameters. Solver then gave the solution shown in cell B2. This shows a clear bias towards the most recent data. The second. Now to compare the alongside X.
Our recommendation to the operations manager, based on the analysis of our findings, is to use the Holt's method of time series forecasting. We have found that Holt's method provides the most reliable forecasting, and we have determined this by calculating the mean average deviation and the mean squared error. We have focused on the mean average deviation for judging reliability because it is less susceptible to the influence of outliers. We have found our forecast for period 25 to be the sale of 46,339 widgets. However, we also have some further recommendations, and this is to procure more data to improve the accuracy of our findings, but also to use the MAPE, or the mean absolute percentage error, as an additional measurement of accuracy. We have recommended this because it is a more easily understood measure of accuracy for business reporting, as it is expressed as a percentage. While we have provided our recommendation to the operations manager and also provided our one-step ahead forecast, we also are aware that you can always improve upon a solution. And so, we have the following suggestions to improve our forecasting method. The first is to use other measurements of error. As we have only used two here, MAD and MSC, we are aware that by using more measurements of error, we can compare them and be sure that we have used the appropriate forecasting method. Additionally, by using measurements of error such as MAPE, we can provide business reporting in terms of percentage errors, which can be more easily understood by all managers, regardless of their knowledge of actual sales figures. Our second suggestion is to compare more methods. We have only been able to use two methods here, and by using more methods, we can be doubly sure that our forecasting method and the one-step ahead forecast provided is the best. Each method has its own weaknesses. For example, although the method we have chosen we have determined to be the best, which is Holt's method, we are also aware that it has its own weaknesses. For example, one criticism of Holt's method is that in the long term, the forecast tends to overshoot the real results. So when providing forecasts more than one step ahead, it might be useful to use methods such as the multiplicative trend method. Other methods such as drift method are quite useful as well because it gains more accuracy by gathering more historical data. Our final suggestion is to compare to competitors. By using other competitor sales figures, we can be doubly sure that our forecast is robust and in line with industry standards. It is well known that employers are looking in recent graduates for more than just hard skills and experience, but also soft skills such as communication, leadership, and teamwork, and the ability to apply those in real world. And so we feel that during the course of this assignment, we have developed some key graduate attributes, specifically professionalism, employability, and enterprise, and in intellectual depth, breadth, and adaptability. We feel that professionalism, employability, and enterprise have been demonstrated when we have set meetings and targets and objectives and met them, but also when we have communicated to each other our research findings and used that communication to determine what should go into this presentation. Our enterprise has been judged by our real-world application of our academic knowledge into a business solution. Our intellectual depth, breadth, and adaptability has very much been demonstrated as we seek to apply our academic knowledge by learning more about the uses of our forecasting methods, where they are the most appropriate, and why we should be able to apply them to this one step ahead forecast that we have produced. So we feel that in the course of our research and our explanations of what is most appropriate, and also in the putting together of this presentation in spite of any difficulties, discussions and debates, we have displayed intellectual depth, breadth and adaptability. It is well known that